So a dilation is a particular type of transformation where we change the size but not the shape of a particular object. So let's take a look at an example and see whether, in fact, this particular transformation is a dilation or not. So we take a look at the original shape, which is this triangle ABC in blue, and the question is, it's been transformed to A prime, B prime, C prime. That means that this point got transformed to here, this point got transformed to here, and the C got transformed to C prime, and then the sides of the triangles followed suit. Well, let's see. Is it possible that this is a dilation? That is, are we just changing size but not shape? Well, let's take a good hard look at the original triangle. If we look at it closely, we actually see that this is an example of an isosceles triangle in the sense that this side is the same length as that side. So these two sides are equal. But in the transformed version, you'll notice that, in fact, none of the sides are equal. This is an example of what's sometimes called a scalene triangle. All the lengths have different sizes. So therefore, here the shape was changed. This is not an example of a transformation known as dilation. This is a non-dilation transformation. Well, here we see two triangles. They actually happen to be right triangles, and you can see the purple one in here, UST, lies right in here, and that's going to be transformed to the red triangle, U prime, S prime, T prime. And the question is this transformation actually a dilation, a special type of transformation where the size is changed but not the shape? Well, let's take a look at the various proportions here and the dimensions. Well, so this length here we see, this is 2, 4. Each of these units represents 2. So this has length 4 by 4. And what about the red one? Well, that has length 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. So we see that this is actually a 12 by 12. So this 4 by 4 became a 12 by 12. You see the size was the only thing that was changed. Otherwise, the shape is identical. So in fact, these two, in fact, are dilations. This is a dilation of the original. And in fact, we could actually talk about the scale factor. What do I have to multiply these lengths by in order to make it sort of blow up to this? In this case, the scale factor is 3, because this length is 4, and I want it to be 12, so I've got to multiply that length by 3. Similarly here, if I take that length and multiply it by 3, it expands to this, and if I take this length and multiply it by 3, it expands to that. So this transformation is actually an example of a dilation.